Hi, I'm Ty Anderson. Welcome back to our series on SKNA analysis. Today we'll be focusing on postural analysis. This analysis utilizes the accelerometer feature of the Bitium Pharos. So make sure in your Bitium Pharos manager you have the accelerometer feature turned on. You can find the accelerometer feature in the red box I've highlighted. The accelerometer feature in the Bitium Pharos utilizes gravity to create x, y, and z coordinates. So when the device is on the patient's chest and the patient is standing up, the x coordinate is pointing down, and when the device is on the patient's chest and the patient is lying down, the x coordinate is pointing horizontally while the z coordinate is pointing up. So we're going to open up the lab chart file that we were using before, except I'm going to go back and search for the EDF file that we started with, or the raw data. And so this time, notice how I will make sure that accelerometer X, Y, and Z is marked. I'm going to deselect marker channel, but I'm going to make sure the accelerometer channels are marked. Now that lab chart has loaded, let's explore our data a little bit. The first thing always is to go to the bottom bar and right-click and change to Show as Time of Day. That way we're able to see the date that the recording occurred and the time. I'm also going to zoom out to give a more comprehensive view, and I'm going to auto-scale. You can see clearly on the top there's a very clear ECG signal. Now we know that the top channel is the ECG channel, and the next three channels are accelerometer X, accelerometer Y, and accelerometer Z in that order. We can double check by going to Setup and to Channel Settings to see exactly what each channel represents. You can tell here that at 10:34 a.m. the patient has a significant movement where accelerometer X rises quite a bit and accelerometer Z also rises quite a bit. Exploring our data, to me it seems like there might be some walking or some sort of motion in this area of the recording. And the patient is once again very still in this area of the recording. I see the line goes out of view for accelerometer Y, so I'm going to press auto scale again. And now it's back into view, and we see that accelerometer Y rises at this time in the day. So next, I'm going to go up to Datapad and go to our Datapad view. And in our Datapad view, we have four different channels. We have the ECG channel, accelerometer X, Y, and Z. So the first thing, I'm going to turn off the ECG channel because that data is not useful to us here. I'm also going to expand this window, and I'm going to select two more things that are important to us, which are the date and the time. Again, for both date and time, we select the area in the column, we go to Selection and Active Point, and we select date and time. Now that that's selected, we can go back. If you remember in a previous episode when we did our basic SKNA analysis, we cut off the beginning and the end of the recording. So we started at 10:31 a.m. and we went all the way to the end and cut off all the noise at the end where the patient took off the monitor. This time I'll show you another way where instead of analyzing the whole file, we'll just be analyzing a selection. So I'm going to go to the end of the recording where I see that the recording ends, and I'm going to hold down Shift and click. That highlights everything in between the two places I clicked. So now I can go to Multiple Add to Datapad, and this time, instead of stepping through the whole file, I'll be using the current selection. And instead of analyzing every second, we want to be analyzing every minute. And I always allow the final selection to be shorter. Now I'm going to select Add, and we can go to our datapad and check out our data. So you'll see all our data is here with the date and the time. That way we can match it up to our data in our Excel worksheet. So I'm going to copy this data, and I'm going to take it to our Excel worksheet where I will paste our data and use a template. So I'm gonna right click and select paste where I see our accelerometer X, Y, and Z data, as well as the date and the time. And notice the time's in the wrong format, so I'm just gonna turn that into time format, and this happens sometimes when we copy over from LabChart to Excel. So I'm gonna change the headings here real quick and delete the first two rows. Now I've already pulled up a template here for postural analysis. This is the template that I use. So the data that we're going to need is the date, the time, the average SKNA, the heart rate, the LF-HF ratio, and then accelerometer X, Y, and Z, and where there's noise. So I'll go back to our blank worksheet, and let's start with the accelerometer, or let's start with the date and the time, where I will paste it over here. And you notice that with our spectral analysis, or SKNA analysis, we have the exact same date and time, and they match up perfectly. So 10:31 a.m. here and 10:31 a.m. here. So here I'll copy over ASKNA and heart rate, as well as low frequency high frequency ratio, as well, and make sure this is pasted as values, or else the data is going to change based on the formula, because there's a formula here. And I'm also going to copy and paste the noise that we did in our very basic SKNA analysis. And now we can bring over this accelerometer data, great. So in these cells and in these columns, we have a couple formulas. This first one is really important. This one says that if accelerometer X is greater than 707.1, then the patient is upright, and if X is less than 707.1, the patient is lying down. Now, this is a calculation that a member of Dr. Chen's lab made to determine where 45 degrees is. So based on this 45 degrees of postural threshold, we consider the patient to be upright or lying down. This cell says that if the previous 5 positions are lying down and the next 5 positions are upright, we consider that a transition. So transition is 1 and everything else is a 0. This one says that if there is no noise and if there's a transition, then we should take an average SKNA of the previous 5 minutes. And this is a similar equation. I'll expand these out so that you can see them. But there's a similar equation here for SKNA when the patient is upright. So this is the 5 minutes after a patient gets up after lying. So this is the heart rate 5 minutes before the patient transitions from lying to upright, and this is the heart rate 5 minutes after the patient transitions. And this is the max heart rate 5 minutes after the patient transitions from lying to upright. The delta as well is the change in max heart rate minus the heart rate upright. So this measures the difference in heart rate when after the patient transitions from lying to upright. And then we have our low frequency, high frequency ratio, which gives us a sense of sympathetic and parasympathetic dominance. And this is the same criteria where we look at before the transition lying to upright and after the transition lying to upright. So now that we've selected the bottom right corner and dragged out our template a little bit, all our data should be here. You notice it's very blank. And how it works is whenever there is a transition, we have corresponding values here. So I'll explain this a little bit more, but first I'm going to go down to the bottom of our worksheet and make sure that our formulas didn't go too far, and they did. So I'm glad I double-checked that. It looks like there's no data in the last column here as well, so I'm just going to delete this last row and delete everything that comes after as well. Just to clean up our data set a little bit. Good. Just fix the last formula here, and we're good. So I'm going to go all the way back up to the top, and I'm going to let's explore our data a little bit with this postural analysis. I'm going to highlight everything, and I'm going to select filter. Now that I've selected filter, I want to key in on all our transition states. So it looks like this patient transitioned 4 times from lying down to upright. These 4 times, it looks like the first time the SKNA did not change very much. The heart rate rose a little bit, just 1 beat on average, and the max heart rate was quite high after standing up, and that the low frequency high frequency ratio rose. And if you remember from the spectral analysis, when the low frequency high frequency ratio rises, there's sympathetic dominance. So we can explore our data like this. We can always see what time of day this was and what was happening. I suspect that the first 3 here were naps, and this 7:45 a.m. on the second day was when this patient woke up from sleeping. So we can even zoom in on one of these events. We can take this last one, for example, and we can go back to our lab chart file, and check out 7:45 a.m. on June 2nd. So this is back to the lab chart file. I'm going to select chart view, and I'm going to drag all the way to June 2nd. Oh, went a little bit too far. So we have June 2nd, and I'm using the bottom bar to find 7:45 a.m. And I'm going to auto scale here as well. And here we have it. This is the moment that this patient appeared to be sleeping all this time, maybe rolling around. Just a second right here. And this patient appeared to get up from bed at 7:45 a.m. right here. Good. Now I'll go back to our Excel worksheet, back to our lab chart template, and I'll get rid of this filter, clear filter. And here I have many simple formulas just to summarize the data that we were able to extract from this patient. So we have number of transitions was 4 for this patient over these 2 days. We have the mean SKNA while lying down, the mean SKNA while upright, and this is of course the mean SKNA 5 minutes before the transition and mean SKNA 5 minutes after the transition, and same criteria with heart rate and low frequency, high frequency ratio. You notice here that the heart rate rises when the patient goes upright. This is something that we would expect. And something that I would expect is for the low frequency, high frequency ratio to rise when this patient is upright. But this patient's data suggests that it actually went down when the patient went from lying to upright. I hope you found this video helpful, and I hope you enjoyed this series as a whole. Thank you for watching.